Hello students, my name is Dr. Gajendra Purohit and you're watching our YouTube channel where I upload videos on engineering, mathematics and B.Sc topics. I've recently started covering discrete mathematics and I've already uploaded 2 to 3 videos. Today I'm going to explain Venn diagrams to you. This concept is fundamentally about understanding sets through pictorial representations, which are crucial in exams for B.Sc or engineering courses or any other course that includes discrete mathematics in its syllabus. This topic is covered somewhat in all these exams, and ultimately the concepts of the principle of inclusion and exclusion often come up in exam questions. My series on discrete mathematics will be very helpful in understanding it through these concepts, and you can click on the I icon and watch my other videos too. So let's begin this session. First, let's talk about what a Venn diagram is. Even though you might have studied it back in the 11th grade, here we delve a little deeper. So listen, what is a Venn diagram? A Venn diagram is a way to represent sets pictorially. This will give us a Venn diagram. For instance, if you're given two sets, A and B, and you're asked to show their union. So the union means elements from both A and B are considered, right? This is how we represent this pictorially, and we represent this union through a Venn diagram. If I say that we do have A and B, but we need to show the intersection of sets A and B, that is their common elements. So this is how we show it in our diagram. Clear? On our diagram, where we have U, it is a universal set. We will understand this further with the help of an example. Let's say if we are given a set I, or let's say we are given a set U. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I take a subset A of this, with elements 2, 4, 7, 8 and 9, and another subset B with elements 1, 3, 5, 8 and 9, right? Now if I tell you to consider A union B, so this is how we will represent it with a Venn diagram. This is our A and this is our B, clear? Now we will write down the element. So A's element is 2. First, we'll check which are the common elements. So here we have 8 and 9 in common. And I guess there's nothing else in common apart from 8 and 9. So here, 2, 4 and 7 will come. And over this side, we will get 1, 3 and 5. Since we got the common elements, it will denote the union. This will show union as a total. Now there are a few elements which do not form a part of the union. Like 1, 2, 3, 4, 5, 6 is missing. So 6 will come here outside. Similarly, 7, 8 and 9 are there and 10 is missing. So 10 will come here outside. So this is what our Venn diagram will look like. Now if we discuss the union, the Venn diagram will clearly show all elements combined from sets A and B. For A intersection B, it's where both sets overlap, showing common elements like 8 and 9, right? For A minus B, it refers to elements in A that are not in B, like 2, 4 and 7. So this is how we can find out these types of elements. Similarly, the complement of A would include all elements that are not in set A, such as 1, 3, 5, 10 and 6. This will be the A complement, right? So we can very easily understand this, as I will explain to you. If you're asked for A union B, then the Venn diagram simplifies the visualization of A union B elements. You can clearly see it includes 1, 2, 3, 4, 5, 7, 8, 9. Similarly, A intersection B, then it will be 8 and 9. If you're asked to calculate the value of A minus B, then you simply need to consider A's value without B, which will be 2, 4, 7. And for A complement B would include all the elements except A. Simply exclude A elements, that is 2, 4, 7, 8, 9. So the complement will be 1, 3, 5, 6. And 10. So this will be A complement B. This is how we can easily understand the concepts with the help of a Venn diagram. Is it clear? It is a powerful tool in set theory because with the help of the diagram, it becomes very easy to grasp these concepts. I will try to make you understand better with the help of an example. But before that, let us understand two basic principles, that is, principle of inclusion and principle of exclusion. I will explain you with the help of a diagram. Suppose we consider a universal set U, and within it we have the subsets A1 and A2, right? If you're asked about the union of A1 and A2, meaning if you're asked to find out the union of A1 and A2, whenever I talk about union, as here we have to find out a union of A1 and A2, n means the number of elements in A1 and A2. So while finding A1 union A2, we consider all elements in both A1 and A2. And while considering elements of A1, we will have all these elements. Similarly, while considering elements of A2, we will have all these set of elements. Clear? So as you can see, we are counting some elements twice, once from this side and once from that. So to rectify the double counting error, subtract the double counted elements. This is why we will deduct A1 intersection A2. It's crucial to remember that while we include n A1 and n A2 in our count, we must exclude the double counts. Hence, it is called the principle of inclusion and exclusion, right? It's important to understand this theorem. The union of n A1 union A2 is equals n A1 plus n A2 minus n A1 intersection A2. 3 sets, it becomes n A1 union A2 union A3 is equal to n A1 plus n A2 plus n A3 minus section of all three. The proof of this is straightforward and we can understand it easily. Though such proofs aren't always asked in exams, however, they form the basis of many common questions in exam. Now let's dive into a problem. We have 100 students, 32 are studying mathematics, 20 are studying physics, and 45 are studying biology. 15 are studying both mathematics and biology. 7 are studying both mathematics and physics, and 10 are studying both physics and biology. Additionally, 30 students aren't studying any of these subjects, which means if we include these 30 students from 100, then 70 students are studying and are distributed among these subjects. Find the number of students studying all three subjects and find the number of studying exactly one of the three subjects. We are supposed to solve these two questions. You might get confused by just looking at it. But let's solve this using a Venn diagram concept, which makes it much easier. So there are 32 students studying mathematics, 20 students studying physics, and 45 studying biology. Also, 15 are studying both mathematics and biology, 7 are studying both mathematics and physics, and 10 are studying both physics and biology. So let us first identify the common number of students studying all three subjects. For this, the understanding of the theorem is a must, which is n of mathematics union physics union biology is equal to n of m plus n of p plus n of b minus. Here the principle of inclusion and exclusion will apply. nm intersection p minus nm intersection b minus np intersection b plus intersection of all three. That is nm intersection p intersection B. Also, we've been given that those 100 students, 30 are not studying at all. This clearly indicates that union will have 70 is equal to NM, which is given to us as 32, NP is 20, and NB is 45, minus its intersection, which is 15 minus 7 minus 10. We've simply substituted all their values and we will try to solve this. But here in our equation lastly, we will have n of m intersection p intersection b, right? Now we will simply try to find the value of by finding the total students in the intersection, meaning how many students are studying all three subjects. So now we will find its value here. So n of m intersection p intersection b is equal to 70. We will solve this equation. 10, 15, this is 30. And we deduct 17 from 30, so we get 13. And here we will get 45 and 20, which is equal to 65. If we deduct 65 from 70, we will get 5. So these 5 students are studying all three subjects. Clearly, we've understood from this information that students are studying all three subjects. Now, if you have clearly understood the complete data, you can simply create a Venn diagram and all your conceptual questions will be answered easily. We have identified that 5 students are studying all three subjects. So now let's get to the Venn diagram. This is how we will create the Venn diagram. Clear? These students are studying math, these are studying biology, and these are studying physics. And we have clearly identified that 5 students are studying all three subjects. So we will keep that common here, in the center. Now we will look at those students who are studying math and biology. Total students studying math and biology are 15. But 5 are already present here. So the remaining will be 10 students, and that will come here. Total students studying mathematics and biology are 15. 5 are common ones and 10 others. Now 7 students study mathematics and physics, meaning of those total 7 studying mathematics and physics, 5 are already here. So this will become 2. Next 10 students are studying physics and biology. For physics and biology, 5 is here in the common, which gives us remaining other 5 students are studying both these subjects. After that, let us consider the students studying only mathematics, which is 32, among the mathematics studying students, which will come here. But 10 plus 5 plus 2 is equal to 17. So deduct that 17 from 32, which will give us the remaining count of 15 students. Now let's consider the 20 students studying physics. Among these 20 students studying physics, we will deduct the overlaps. That is 5 plus 5 plus 2 is equal to 12. So the exclusive number of physics is 8. You need to keep this in mind. For the 45 studying biology, this will be the region of biology. The overlaps here are 5 plus 5 plus 10 is equal to 20, and reducing them from 45 will give us 25. This breakdown helps you visualize how the Venn diagram segments the students. Now addressing the specific question, find the number of students studying all 3 subjects. How many students are there who are studying all 3 subjects? We have identified that 5 students are studying all 3 subjects. The answer for this will be 5, right? Now the next question is, find the number of students studying exactly one of the 3 subjects. How many students are studying exactly one subject? For students studying exactly one subject, 15 are only in mathematics, 25 only in biology, and 8 only in physics. So students studying exactly one subject is equal to 15 plus 25 plus 8, making a total of 48 students. So if you have understood this concept clearly, then you can quickly solve the question. This is the solution, which I just explained to you in depth. As we calculated, 48 will be the answer. Moving on to another set of data regarding language studies. Out of 120 students surveyed, it was found that 20 students studied French, meaning number of our students studying French is equal to 20. 50 students have studied English, meaning N of E is equal to 50. And 70 students study Hindi, which means N of H is equal to 70. For overlaps, 5 study both English and French. So N of E intersection F is equal to 5. Moving on to another set of data. 20 study Hindi and English. So N of E intersection H is equal to 20. And lastly, 10 study both Hindi and French. So N of H intersection F is equal to 10. Clear? And 3 students study all 3 languages, which will be N of F intersection E intersection H is equal to 3. Let us understand this with the help of a Venn diagram. Using a Venn diagram, we start by placing this data, which will make it clearer, and we can answer the questions individually. For the Venn diagram, we will consider the 3 students who study all 3 languages at the intersection. Similarly, this will be French, this will be English, and this will be Hindi. This will make it easier to understand. Now, what is given in the question? For those studying English and French, a total of 5 are studying, but 3 is already here. So 2 additional students are exclusive to that, making a total of 5. Similarly, for 20 students studying English and Hindi, after considering 3 in the center, 17 students will come here. And for 10 students studying Hindi and French, after excluding the common 3 students, 7 are exclusive and it will come here. Clear? Next, we have 20 students studying French. So for the part of French, of those 20, we will deduct the 12 in the overlap. I will denote this with a different color here, which will give us the remaining 8 students. Similarly, for the 50 students studying English, we will deduct 17 plus 3 plus 2. 22, which will give us 28. Clear? And lastly, we will look at the 70 students studying Hindi. We will deduct 17 plus 3 plus 7, 27, which will give us 43. Clear? Now let us consider each question. First one is, find how many students have studied Hindi alone. What is the number of students studying only Hindi? Students studying only Hindi will be 43, right? The next one is how many students are studying French alone. The answer will be 8. How many students are studying English but not Hindi? These are the English studying students, but who are not studying Hindi. We will exclude these since they are not studying Hindi. So it will be 28 plus 2 is equal to 30. Now we'll write down each one's answer. Students studying Hindi alone will be 43. Students studying French alone are 8. Students studying English but not Hindi are 17 plus 3 is equal to 20 of Hindi will be deducted. Because those students who are studying English and not Hindi, and that will be 28 plus 2, which is 30. The next question is, which students are studying Hindi but not French? The students who are studying Hindi but not French are 43 plus 17. Apart from this, will be equal to 60. All these are the answers to individual questions. And this visualization with the help of a Venn diagram helps us clarify the distribution. For the third question here, in a group of 191 students of which 10 students are taking English, computer science and music. Okay, let me just write down the data which will make things easier for us. Okay, for the first part, students studying English, computer science and music. That is N of E intersection C intersection M is equal to 10. Next, 36 are taking English and computer science. So N of E intersection C is equal to 36. After that, 20 students are taking English and music, which means N of E intersection M is equal to 20. And 18 students are taking computer science and music, which will be N of C intersection M. And 65 students are taking English, which means N of E is equal to 65. And 76 students are taking computer science, so N of C is equal to 76. And lastly, 63 students are taking music, which means N of M is equal to 63. As you can notice, there are 3 to 4 questions asked here. To answer them, we will firstly make a Venn diagram. In the first question, I had used the principle of inclusion and exclusion, but I did not apply that in the second question, and it is not necessary to apply it here too. How to know when to apply and when not to apply? I will say that if you have already been given the value of intersection, then there is no need to apply that principle. And if the value of intersection is not given, then you must apply that principle. Now let's summarize and clarify the breakdown with the help of a Venn diagram. Now for the given data set, this will be English, this will be computer science, and this will be music. Now students who are common to all 3 subjects are 10. Next, for English and computer science, 36 students are studying English and computer science. 10 are already here, so remaining will be 26, which will come here. For English and music, 20 students are studying English and music. 10 are already included, so the remaining will be 10 students. Next, for computer science and music, 18 students are studying. 8 will come here since 10 are already included in the overlap. Now we will move ahead to this part. Students studying only English are 65, of which 26 plus 10 is equal to 46 are already included. Now to calculate students studying only English, we will deduct 10 plus 26, 46 from 65, which is equal to 19. Moving forward, 76 students are studying computer science. Of those students studying computer science, these overlapping students are also present. So we will deduct 26 plus 10 plus 8, that is a total of 48 from 76. It will result in 32. We can verify it by adding everything back. That is 32 plus 8 plus 10 plus 26 is equal to 76. So it is correct. Next, we will move forward to students studying only music, which is 63, of which we will deduct 10 plus 8 because that is already present. So that will be equal to 28. So 63 minus 28 is equal to 35. Now coming to the questions part, the first one is, how many students are taking English and music? Which means English and music are common here. So this part is common here, right? This section will be the common students studying English and music is 20. The next half of the question is, but not studying computer science. To get the answer, we will remove computer science from here like this. But we need to exclude computer science, which means this 10 will be deducted. So our final answer will be 10. The next question is, how many students are taking computer science and music? So let's see, computer science and music are here in this section, but the next part of the question is, but not studying English. So firstly, students studying computer science and music are 10 plus 8, which is equal to 18. But we need to deduct those students who are studying English. So deduct 10 and our final answer will be 8. First question is, how many students are taking none of these 3 subjects? Total student strength is 191. We will now deduct all these values from 191 because this is the total strength of students who are studying. Let's break down the final tally of students who are not enrolled in any of the subjects of English, computer science or music based on a total of 191 students. 19 plus 32 plus 35 plus 26 plus 10 plus 8 plus 10 is equal to 140. We will now deduct this 140 from 191, which will be equal to 51. Therefore, 51 students are not participating in any of the subjects of English, computer science or music. So with the help of a Venn diagram, we can understand and solve each question very easily. Here's the solution to the said problem. This is our data and here we have simplified it. And here we can tally our answers. Thank you so much for watching my series. Do comment and give me reviews and your feedback about my series. In the coming time, I'm planning more videos exploring topics like relations and functions, and later on graph theory will be covered. You can even watch my playlist on Discrete Mathematics by clicking right here. My content can indeed enrich viewers preparing for exams like IIT-JAM, CSIR NET and GATE. You can access my playlist from here, and if you wish to subscribe to my channel, then click here and click here to follow me on Instagram. Thank you so much everyone.